So, the last couple lessons explored the idea of what it means to have exponents that are negative. And we looked at a variety of questions involving negative exponents or integral exponents. Again, integers being numbers that may be negative but are whole values. And so we saw that a negative power essentially means repeatedly dividing. And if you have a negative power in the denominator, in the end it means you're repeatedly multiplying. Because you're dividing by dividing. And we worked with a variety of things. And by the end, some pretty complex algebraic work where we had to combine our knowledge of previous exponent laws as well. Well, this is now looking at what it means to have a rational exponent, which means an exponent that's not a whole number. It may be negative, but it's not a whole number. And we'll explore these ideas in class, but to get straight into it, I start with 64 to the power of a half. So what does that mean? Well, a power of 1/2 actually means the same as a square root. And so the square root of 64 and 64 to the power of 1/2 mean the same thing. Chances are this looks more familiar to you, but they're both exactly equivalent. One's not better than the other, just a square root is what you're more used to seeing most likely. And so the 64 to the power of 1/2 equals 8 because the square root of 64 is 8. And so in general, nothing special about the number 64 aside from it being a perfect square, so it's a bit pleasant when you're dealing with square roots. But in general, anything to the power of 1/2 is the same as a square root of that value. Every time you see a power of 1/2, you want to think of square root. Now keep in mind, a square root, it's not wrong to put a 2 right here. We just don't usually do that. But that kind of gives you a hint about how these kind of connect. Again, we don't usually put a 2 there, so I'm going to erase that in a moment. But if we don't see a value right there, it means a square root. But you could put a 2 there as well, which leads me to what a power of 1/3 means. And hopefully you can guess that if a power of 1/2 means a square root, a power of 1/3 is a cube root. So 64 to the 1/3 is the same as the cube root of 64, which means whatever number times itself 3 times equals 64, and that's going to be 4. And so again, 64 is kind of pleasant because it's both a perfect square and a perfect cube. But in general, if you have any number raised to the power of 1/3, that is equivalent to that same number finding the cube root of it. Now, square roots and cube roots aren't the only types of roots. And we can start to combine things together. And so what if I have something like this? What if I have 8 to the 2/3? Well, what does this mean? And what does it equal? But more importantly, what does it mean? Well, what I'm going to do is I'm going to rewrite this to kind of show you what it means. I'm going to rewrite it like this. I'm going to rewrite it as 8 to the 1/3 all raised to the power of 2. So first of all, notice that even though you may have not thought about this in advance, it is definitely correct because I have a power raised to another power. When you have a power raised to another power, you multiply the exponents together, and 1/3 times 2 does equal 2/3. So what I wrote down here is more messy than what I gave you here in many ways, but it's correct. So why did I do that? Good question. Because 8 to the 1/3 we saw already now must be the same as the cube root of 8. And so what does 8 to the 2/3 mean? It means what you see right here. 8 to the 2/3 means the cube root of 8 all to the power of 2. That's what it means. It means a combination of a cube root of 8 as well as a power of 2. And it doesn't actually matter what order you write this down. The way I have written down right now, it has the cube root first being all squared, but in the end it's all the same. If I did this, if I did 8 squared and then found the cube root, it's going to be equivalent. It's all the same thing. And it all equals 4. But again, I don't really care about the number 4. But that's what it equals. And again, notice right here, if I look at this first, the cube root of 8 is 2, because that means what number times itself 3 times equals 8? 2 to the power of 2 equals 4. However, if I look at this form, the first thing I would do is 8 to the power of 2, which is 64. And then the cube root of 64, we saw that just a few minutes ago, it's 4. It doesn't matter which way you look at it. Okay, they're all equivalent. And so which leads me to this right here. X to the power of a over b, where a and b can be any numbers, including negative numbers. In general, what this means is the bth root of x, b, it could be a second root, a cube root, a fourth root, a 10th root, whatever, all to the power of a. That's one way of looking at it. Or you could look at it the other way around. in the other order. You could think of this as x to the power of a all to the bth root. It's kind of weird saying bth root. You have to have kind of a lisp as you say it, but there's no other way around it. And so in general, you can see that when you have fractions in your exponents, the numerator relates to the power over here. The denominator relates to the radical, which is what we call the root. And it's actually, we call that b, we call the index of the root. A square root has an index of 2. A cube root has an index of 3. A sixth root has an index of 6. But again, I never really care too much about terminology, more so that you actually understand this sort of connection here. Okay, so that said, we can also combine this with anything we've done before. We can work with negatives, and that's where things will especially start to get a bit more challenging. But first, let's evaluate these 4 without a calculator. All right, so 121 to the power of 1/2 doesn't mean half of 121. It means the square root of 121. That's what that means. And going forwards, every time we see a power of 1/2, we want to think the square root. And if you know your 11 times tables, you know that 11 times 11 is 121. So that equals 11. 125 to the power of 1/3. We've seen that's the same as a cube root. So this equals the cube root of 125. And what times itself 3 times equals 125? Just 5. So now we have a power of 1/4. I haven't seen this directly, but that means the 4th root of 16. Which means what factor, what number times itself 4 times equals 16. And we're getting to some different roots here, but in general, just make a guess. I don't know, 4. But 4 times 4 times 4 times 4 is definitely a lot more than 16. And so it shouldn't take us too long to realize this must equal 2. Because 2 times 2 times 2 times 2 does equal 16. All right, lastly, 16 to the power of 3/4. Well, we saw this at the end of our sort of examples from just a minute ago. This is a combination of things. So this means a 4th root of 16 all to the power of 3. Or I can think of it as 16 to the power of 3 and finding the 4th root of that. That said, of these two things, they're both correct. This one I think is superior because it's way easier. Even with a calculator, this is easier. Because for here, I have to think about, first, what is the 4th root of 16? We already know that's 2. And then 2 to the power of 3 means 2 times 2 times 2, so 8. So I know this is going to be 8. Whereas if you look at this form, which is not wrong, but it's a lot harder, first you got to think about what is 16 to the power of 3. 16 times 16 times 16. Again, you're not really supposed to be using a calculator. And whatever that big number is, you then have to find the 4th root of all of that. You're going to get the same thing, but you're way better off thinking about this. Mainly because, first, I'm dealing with smaller numbers. And so the 4th root of 16, we already saw is 2. 2 to the power of 3 means 2 times 2 times 2, which is 8. All right, so what if I incorporate some negative exponents in here as well, or have negative exponents in the denominator? So let's look at this first one. 121 to the negative 1/2. Well, we know that I don't care what the exponent is. A negative exponent is always the same as a positive exponent in the denominator. And so 121 to the power of negative 1/2 must be the same as 121 to the positive 1/2 in the denominator. Right, and we saw that before. Again, it doesn't matter if it's the exponent is a fraction. If the exponent is negative, it's equivalent to division. In this case, you're dividing by the square root of 121. And we already saw the square root of 121 is 11, so the same as 1/11. Which, notice, is actually not surprising if I zoom out here to see how these two questions here relate to one another. 121 to the 1/2 is 11. 121 to the negative 1/2 is 1/11. We saw that sort of stuff all the time before. That's it. I'm going to just focus on these ones here. OK, 125 to the negative 1/3. Well, again, this must be the same as 1/125 to the positive 1/3. And we already saw that a power of 1/3 means a cube root, so this is the same as 1 over the cube root of 125, which is 1/5. All right, so next, 1 over 16 to the power of negative 1/4. First, let's just rewrite this without a negative exponent. That's what I've been doing every single time. And so dividing by a power that's negative is the same as having a positive power in your numerator. So I could say it like this. Now I don't really need that over 1, so I'm going to erase that in a moment. And again, we saw that all the time before. A negative exponent in the denominator is the same as a positive exponent in the numerator. So since I don't really need that over 1, let me just erase that. And then I have 16 to the power of 1/4. Well, we already saw that's the same as 2. Right? This means the 4th root of 16, which equals 2. We worked that out already. And so similarly over here, 1 over 16 to the negative 3/4. It's needlessly messy. It's the same as 16 to the positive 3/4 in the numerator. And again, since I don't have anything left in the denominator, I don't really need that over 1 anymore. And again, 16 to 3/4 we worked out just up here. Right, it equals 8. So I have the exact same thing here, so I don't need to rework it all out. I know it's going to equal 8. All right, so the last couple examples involve dealing with variables. And again, we always have lots of options. Don't get too scared off by it. In the end, though, I want to simplify each. And so in general, when I'm saying simplifying, I don't want any negative exponents in my final answer because they're not that simple. That's it. Let's look at this one first. X to the power of 5 times x to the power of negative 1/2. Well, there's a few things I could do, but notice I'm multiplying powers to the same base. So I'm going to add my exponents together. So this must be the same as x to the power of 5 plus negative 1/2. Or 5 take away a half. And so what is 5 take away a half? I want to stick with fractions here. And so I'll make a little note right here. You know, I essentially have 5 minus a half. And let's remember some good old grade 7 math, grade 8 math. I need to find a common denominator. That right now that's a 1, so let's change that to it. I got to double that and double that. So I have 10 over 2 minus 1 over 2, which is 9 over 2. And that's what I want to bring to my final answer. So this equals x to the power of 9 over 2. Okay, so with that said, I have no more negative exponents in my expression, so I'm done. Let's look right here for the very last question. One thing I would recommend doing is taking this 0.5 and writing it as a fraction. I'll do it right away. Why do I recommend that? Because when I write it as a fraction, it's more clear to me that that power of 0.5 means a square root. Now it's negative 0.5, so I'll get to that in a bit, but it makes it more clear to me that's a power of a square root. That's it. Before I even get to that, I'm going to use my exponent laws. I have multiple factors inside the brackets, all being raised to the power of negative 1/2. So let me raise them all, and don't forget about the 16, to the power of negative 1/2. And so I'll just write it up first as 16 to the negative 1/2. Times x to the 3 times a half is 3/2. 3 times negative 1/2 is negative 3/2. Times y to the power of negative 1/2. Well, sorry, 4 to the power of negative 1/2. 4 times a half is 2. So 4 times negative 1/2 is negative 2. All right, so now I got a lot of negative exponents. In fact, everything's negative. So I can rewrite all of this as positive exponents in the denominator. So 16 to the negative 1/2 means 16 to the positive 1/2 in the denominator. X to the negative 3/2 in the numerator, positive 3/2 down here, and y to the positive 2 down there. Don't forget my numerator, I have to have something up here, so 1, right, because everything's in the denominator. And now all that's really left is this 16 to the 1/2, because everything else is fine. X to 3/2 is, you know, it's in lowest terms. It's a positive number. What does 16 to the 1/2 mean? It's not 8, it's 4. And that's because that means 16 to the 1/2 means the square root of 16, which is 4. So I have 4 times x to the 3/2 times y squared, and all of that is in the denominator. So this is my final answer. Lots of little steps there. So again, it's all about being kind of detailed with each various step. And there's always more than one way of getting to this, but there is just one simplest answer for all of these. All right, you definitely need some practice, but we don't need to have any more long-winded notes than this. So I'm going to stop.